Hello everyone. In this particular video, we are going to solve the problem number 1.40 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A particle moves along an arc of the circle of radius r. So let us say this is the circle of radius r in which the particle is moving. According to the equation, L is equal to A sine omega t. L is equal to A sine omega t, where L is the displacement from the initial position measured along an arc, and A and omega are constants. And it is given that r is equal to 1 meter, A is equal to 0.8 meter, and omega is equal to 2 radian per second square. And here A and omega are constants. Now, as the particle is moving in the circular path, the velocity will always be in the tangential direction. Okay, and in the first part of the problem it is asking to find the magnitude of the total acceleration of the particle at the points L is equal to 0 and L is equal to plus minus a. So basically at any point, at any position, we are having two component of accelerations. One is in the tangential direction or along the direction of velocity. Let us denote it as at, which is the tangential direction, and another component is towards the center. Let us call it as AC. So that is the centripetal or the normal component of the total acceleration. Okay, so if we write at, that we can write it as dv upon dt. Okay, so let us first find out the expression of velocity. For that, let us differentiate the displacement with respect to time. So we can write it as d by dt of a sine omega t. Okay, as a is constant, we can take it outside and we can get a times d by dt of sine omega t, and the differentiation of sine omega t is omega times cos of omega t. So from here we will get a omega cos of omega t. So the expression of velocity we will get it as a omega cos of omega t. Okay, now if we find the expression of at, that we can write it as dv upon dt, that is equal to d by dt of a omega cos of omega t. Again, a omega is constant, so we can take it outside and we can write a omega d by dt of cos of omega t, and the derivative of cos of omega t is minus omega sine of omega t. So we will get minus a omega square sine of omega t. So the expression of at we will get it as minus omega square sine of omega t. Okay, now if we talk about the normal component of acceleration or the centripetal acceleration, that we can write it as AC is equal to v square by r, that is equal to v we have found out as a omega cos of omega t. So a omega cos of omega t whole square by r. So from here we will get a square omega square by r cos square of omega t. Okay, so this is the expression of centripetal or the normal acceleration we have got. Okay, now in the problem it is asking to find the magnitude of total acceleration of the particle at the points L is equal to 0 and L is equal to plus minus a. So what we can do, we will find out the tangential acceleration and the centripetal acceleration at those locations, and then we will find the total acceleration. So let us first consider at L is equal to 0. L is given as a sine omega t is equal to 0. So from here we can write sine omega t is equal to 0, and omega t we can write it as n pi for all n belongs to integer. What I have written here, let us understand by drawing the graph of sine omega t. Okay, so let us say this is y-axis where we can represent sine omega t, and this is x-axis which we can write it as omega t. Now sine omega t will something look like this. Okay, where it is intersecting the x-axis at 0, pi, 2 pi and 3 pi. So the solution of sine omega t is equal to 0. We can write it as the integral multiple of pi. So that's what we have written here. So in this particular case, if we write the tangential acceleration, that we can write it as minus a omega square sine of omega t, and that we can equate it to minus a omega square sine of n pi. And we know that sine of n pi is equal to 0, so the value of tangential acceleration is 0. If we write AC, that we can write it as a square omega square by r into cos square of omega t. Let us substitute the value of omega t and we will get a square omega square by r cos square of n pi, and cos of n pi is either plus 1 or minus 1. Let us draw the graph of cos of omega t. So at omega t is equal to 0, cos omega t is 1, and at pi by 2 the value of cos is 0. So the graph will something look like this. Okay, something it will look like this. So we can see at pi by 2 value is 0, at pi it is minus 1, at 2 pi it is 1, and again at 3 pi the value is minus 1. So cos n pi is either plus 1 or minus 1. So from here we will get a square omega square by r. This is the value of centripetal acceleration we got. Now if we write down the total acceleration we can write it as at square plus ac square under root, because both the tangential acceleration and the centripetal acceleration are mutually perpendicular to each other. Okay, here we can see at is 0, so a total we can write it as a square omega square by r. Now substitute the numerical value of all the constants, then we will get 0.8 whole square into 2 whole square divided by 1, and from here we will get 2.56 meter per second square. Okay, now let us come to another position, that is at L is equal to plus minus a. So we can write a sine omega t is equal to plus minus a. So from here we will get sine omega t is equal to plus minus 1. So from here we can write omega t is the integral multiple of pi by 2. Okay, integral multiple of pi by 2. So now let us substitute the value of omega t in at and ac. At is equal to minus a omega square sine of omega t. So from here we will get minus omega square sine of n pi by 2, and sine of n pi by 2 is plus minus 1. So we will get plus minus a omega square. If we talk about the centripetal acceleration, that is given as a square omega square by r cos square omega t. So a square omega square by r cos square of omega t, that is equal to a square omega square by r cos square of and pi by 2. So from here that we can equate it to 0 because cos of integral multiple of pi by 2 is 0. So if we write the total acceleration we can write it as at square plus ac square under root, and here ac is 0, so we can write it as at, that is equal to a omega square. So that is the magnitude of the total acceleration is equal to a omega square. Let us substitute the value of a. So we can write 0.8 into 2 square. So we will get 3.2 meter per second square. Okay. Now let us talk about the second part of the problem. In this particular problem, it is asking to find the minimum value of the total acceleration W minimum and the corresponding displacement Lm. Okay, so in the B part, if we write the expression of AC, that is equal to a square omega square by r cos square omega t, and the expression of AC is equal to minus a omega square sine of omega t. Okay, so the total acceleration, let us say a total, we can write it as ac square plus at square under root, because both are mutually perpendicular. We can equate it to a square omega square by r cos square omega t whole square plus minus a omega square sine of omega t whole square under root. Okay, so from here we will get a to the power 4 omega to the power 4 whole divided by r square cos to the power 4 omega t plus a square omega to the power 4 sine square omega t under root. Okay, now here we want to minimize the total acceleration. For that, instead of minimizing under root the entire expression, if we only minimize the function that is inside the square root, that means we are minimizing the overall total acceleration. Okay, so let us consider it as u. So we can write u is equal to a to the power 4 omega to the power 4 whole divided by r square cos to the power 4 omega t plus a square omega to the power 4 sine square omega t. Let us differentiate this particular expression with respect to time. Then we can write it as du upon dt, that is equal to d by dt of a to the power 4 omega to the power 4 whole divided by r square cos to the power 4 omega t plus a square omega to the power 4 sine square omega t. Okay, as a to the power 4 omega to the power 4 by r square is constant, we can take it outside and we can write a to the power 4 omega to the power 4 whole divided by r square, and the differentiation of cos to the power 4 omega t we can write it as 4 into cos cube omega t. Differentiation of cos omega t is minus sine omega t, and the differentiation of omega t is omega. Okay, plus a square omega to the power 4 is constant, so we can write it as it is, and the differentiation of sine square omega t is 2 times sine of omega t into cos of omega t into omega, that we can equate it to 0 because we want to minimize this particular function. Okay, so from here we can write it as a square divided by r square minus 4 omega cos cube omega t into sine omega t plus 2 omega sine omega t cos omega t is equal to 0. Okay, so let us equate both the expression and we will get 2 omega sine of omega t cos of omega t is equal to 4 a square by r square into omega sine of omega t into cos cube of omega t. So from here omega will get cancelled, 2 4 will get cancelled, and sine omega t will get cancelled, and it will remain like this. So from here we will find that cos square omega t is equal to r square divided by 2a square. Okay, so this is the value of cos square omega t we got. Okay, and the value of sine square omega t, we can write it as 1 minus cos square omega t, that is equal to 1 minus r square divided by 2a square. Right, now if we substitute the value of cos square omega t and sine square omega t in the expression of a total, then we will get the minimum value of the total acceleration. Okay, so let us find out the minimum value of a total. We can write it as a total minimum is equal to, what is the expression, a to the power 4 omega to the power 4 divided by r square into cos to the power 4 omega t, cos to the power 4 omega t, plus a square omega to the power 4 sine square omega t, a square omega to the power 4 sine square omega t under root. Let us substitute the value of cos to the power 4 omega t and sine square omega t. So we will get a to the power 4 omega to the power 4 whole divided by r square. Cos to the power 4 omega t, we can write it as r to the power 4 whole divided by 4 a to the power 4 plus a square omega to the power 4 sine square omega t is 1 minus r square by 2a square under root. Okay, so from here we will get r square will cancel, a to the power 4 will get cancelled, and we will get omega to the power 4 r square divided by 4 plus a square omega to the power 4 minus omega to the power 4 r square by 2. So this is the expression of a total minimum we have got. Okay, all right, we can take omega to the power 4 and r square as common, and we can write it in a simplified form. Okay, now let us find out the value of the minimum distance. So we can write as L minimum, that is equal to a sine of omega t, that we can write it as a times sine square omega t under root, that is equal to a times sine square omega t that we have found out from here. So that we can write 1 minus r square divided by 2a square under root. Okay, so this is the value of minimum displacement we have got at okay, I hope the entire procedure is clear. Thank you.